Hi there. Today we're going to discuss direct variation. Objectives and standards. We're going to find the constant of proportionality to a direct variation from a graph or an equation. We're going to determine if a situation represents a direct variation. We're going to recognize and represent proportional relationships between quantities. We're going to decide whether two quantities are in a proportional relationship. And then we're going to identify the constant of proportionality in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. The vocabulary you need to know for today is direct variation, constant of variation, and constant of proportionality. Make sure you write these down in your notebook. Direct variation. A linear relationship, basically just a line, is a direct variation when the ratio of y to x is a constant, which is k. We say y varies directly with x. What that means is every time you set up a ratio of y over x, it's going to equal the same number, which is going to be k. So as in symbols, it's going to say y over x equals k. Or you can say y equals k times x. So that basically means whatever you multiply x by, which is your k, is going to be the same number all the time. So as an example, y equals 3x. 3 is your constant of variation. That means you're going to multiply 3 times x in any situation. When two variable quantities have a constant ratio, the relationship is called direct variation. The constant ratio is called the constant of variation. The constant of variation is also known as the constant of proportionality. In a direct variation equation, the constant rate of change, or slope, is assigned a special variable k. So again, like I said here, y over x equals k. We're going to divide the y coordinate by the x coordinate to get k, and that's called your direct variation. And then in the other form where they have y equals kx, k, which is a direct variation, is the number you multiply x by to get y. The height of the water is a pool being filled is shown in the graph. Determine the rate in inches per minute. Okay, so this is kind of like we're finding the slope. When we're dealing with this situation, we want to know how much does it increase over time. All right, so since the graph forms a line, we know that it's a linear relationship and that the rate of change is going to be constant, meaning if I divide my y's over my x's for all of these, I'm going to get the same number. So we're going to use the graph to find the constant of proportionality. So again, we're going to divide our y over our x, so our height divided by our time. So 2 divided by 5, 4 divided by 10, 6 divided by 15, and 8 divided by 20. And all of these times I get 0.4. Okay, that's the number that I get when I'm dividing. That's 0.4, 0.4, 0.4, 0.4. So that would mean that my constant of proportionality, or my direct variation, is going to be 0.4. So the pool fills at a rate of 0.4 inches every single minute. Example 2, the equation y equals 10x represents the amount of money Julio earns for x hours of work. Identify the constant of proportionality, explain what it represents in this situation. So this is a two-part question. We have to identify and then we have to explain. So this kind of looks like the equation we already had when we have y equals kx. So y equals kx, and my k is going to be 10. So now what that means is the constant of proportionality is 10. So that means that he earns $10 for every hour that he works. So 10 times the number of hours equals how much money he earns. Determine direct variation. Not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. So if there's no constant ratio or it doesn't start from the origin, there is no direct variation. Okay, that's very important. You have to check the ratios and you have to check, does it go through the origin? If not, there's no direct variation. So pizza costs $8 plus a $3 delivery charge. So the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? Okay, so first we're going to talk about how do we figure out the cost. It's $8 per pizza. So you're going to multiply 8 times the number of pizzas. And regardless how many pizzas you get, you have to pay the $3. So whether you're getting 1, 2, 3, or 4, it's just $3. So as I'm making this graph, I would say 8 times 1, which is 8, plus my $3 delivery equals 11. So then 8 times 2 is 16, and there's a $3 delivery charge, so that equals 19. Now you have to remember, it's not $3 per pizza, it's $3 per order. So that's why we're not adding the 8 plus 3 and then multiplying it times the pizzas. All right, so take a look at this. This is our graph according to our table. Now what you'll notice is it's already not proportional because it doesn't go through the origin. Okay, so we're going to find out why. So now we're going to set up our ratios of our y's over our x, so our cost over our number of pizzas. So 11 over 1, 19 over 2, 27 over 3, and 35 over 4. So if you'll look, you'll notice that all the ratios are not the same. So if the ratios are not the same, it does not have a direct variation. It doesn't have a constant of proportionality, so there is no direct variation. Number 4, determine whether the linear function is a direct variation. If so, state the constant of proportionality. All right, so what we're doing here is 2 parts. You have to determine, is it proportional? Is it a direct variation? And then you have to tell the constant of proportionality. So the first thing we're going to do is we're going to compare the ratios to check for a common ratio. Again, remember it's y over x. So we're going to set up 12 over 1, 24 over 2, and so forth. So we have those 12 over 1, 24 over 2, 36 over 3, 48 over 4. And if you'll notice, they all equal 12 over 1. So the question is, now that we know that all the ratios are equal, what is the constant of proportionality? What did I multiply each one by? I multiplied it by 12. So since the ratios are the same, the function is a direct variation, and the constant of proportionality is 12 over 1. So today we found the constant of proportionality from a graph and equation, and we determined if a situation represented a direct variation. I hope that video was helpful. Thank you. Bye.